Welcome to another video in which we will talk about an important data analysis technique which is known as factor analysis. So, in this video, we'll talk about what is factor analysis. For that, we'll be using an example. Then, we'll talk about its definition. We'll also talk about how we can do this factor analysis in the SPSS. And we will do that using two different sheets. And then we'll also talk about some of the important concepts and how to interpret those concepts using factor analysis technique. For example, composite reliability, ABE, and some other things. At the end, we will also be talking about how to calculate composite reliability and average variance extracted. So let's just understand what is factor analysis. For that, you need to consider this simple example. Let's suppose if you are the in charge of a hostel and you have 50 students and they are new students for you, but in order to place them, you have six rooms, which means you have 50 students and now you have to place them in six rooms. So the question is that which students have the same habits so they can stay in the same room because these 50 are to be divided in six rooms. So for that, just consider that the variables are your rooms and the items that you're using to measure your variable are the students. So we want to see that which items are actually representing which variable. So let's just first see what are the items and what are the variables. Now, in order to understand what do we mean by items and variable, here I have this questionnaire in which I am trying to measure this formalization as a variable. But this formalization variable is being measured by these 7 or 8 items. So we are talking about these items and this is a variable. We want to see that are all of these items measuring the same thing, which is formalization. So let's just go back to our some of the more concepts. Factor analysis is a technique that is used to reduce a large number of variables into fewer number of factors. So for example, if you have number of items, the factor analysis is going to reduce them into set of factors. For example, out of these 11 or 12 items, it is going to create 3 factors. This technique extracts maximum common variance from all variables and puts them into one common score. So we'll talk about this when we'll go to our SPS analysis. Some more things to understand. There are different types of factoring, which means different methods are used to do this factor analysis. The most common one that is used for Likert scale type data are the principal component analysis. For example, this is the most common method used by researchers. It is also known as PCA, which is principal component analysis. Starts extracting the maximum variance and puts them into first factor. Then we have some other methods, for example, common factor analysis, the second most preferred method by the researchers. It extracts the common variance and puts them into factors, the same thing. But this method is mostly used in the SAM analysis, which is the structure equation modeling method. Then we have the image factoring, maximum likelihood method, and some other methods that you can use in order to use your factor analysis. It is not very difficult. Just by clicking the right option in the SPSS, you can use any of these methods. Factor loading is one of the important concepts that we need to understand in order to fully understand what is factor analysis. Factor loadings is basically a correlation coefficient for the variables and factors. Factor loadings show the variance explained by variables on that particular factor. We'll talk about them when we'll go to our SPSS analysis. When we perform the SEM analysis, which is structural equation modeling approach, the rule of thumb is that zero point 0.7 value of factor loading is considered to be an appropriate value. But when we use the SPSS software, we can also take the value which is zero point 0.5 into account. But Here, one thing we need to be very sure of, that not all of our value can be equal to or a little above than zero point 0.5. Many of our values should be above zero point 0.7 in order for other things, for example, composite reliability and ABE values to be showing us zero point 0.5 value or above value. So we'll talk about this when we'll be calculating those things. Then there is another thing that researchers use is the eigenvalues. Eigenvalue is also called the characteristic root. So this is going to give you some explanation about how many factors can we extract from the given items or from the given variables when we do the analysis in SPSS. So eigenvalues shows the variance explained by one factor or by that factor out of the total variance. So we'll also talk about this when we'll go to our SPSS analysis. Then we have some values that we calculate after we get the factor loadings. The important ones are AVE and CR. So first we'll talk about what is AVE. AVE is the average variance extracted, usually known as AVE. These values should be above zero point 0.5. If they are above zero point 0.5, we consider that our scale is reliable, and then we take the square of all the loadings that we get for one factor or one variable, and then we divide them by the number of variables or the items that we are using. So in simple terms, taking average of square of your loadings. For this you can use Excel, that we'll be using at the end. And in Excel, the only issue is that it does not consider raised to power like this. You have to give this raised to power sign in order for it to be considered as the square values. So this is, for example, for the 6 values. We'll go to the Excel and we'll calculate it afterwards. Now, for the CR value, which is the composite reliability, this is also one of the very important indicators in factor analysis. What we can do is, this is the formula that we use to calculate our CR values. But I suggest you go to this website, the statisticalmind.com, and there is this option of composite reliability calculation. And at the end, we'll also be doing this one. So now let's just go to our SPSS sheet and see how we do factor analysis. So this is our first sheet in which we'll be performing factor analysis. Before we start performing, we need to understand a few things. For example, in this sheet, I am taking 3 variables. This F1 to F7 is the variable name formalization. EC1 to EC11 is the employee creativity, and this is another variable. For the third one, we have the 9 items. So these are our 3 variables in this sheet. Now, we need to understand how to perform analysis and what do we mean by different values. So in order to do that, you can go to this analyze and then dimension reduction and factor. So once we are going to click this, it's going to take us to this window. Now here you need to be very careful what you need to insert in this window. So you'll only be putting the items of the variables that you have measured and nothing else. For example, we are left with demographics and some of the computed variables. So we won't be putting them here. We'll only be putting the items that we're using to measure our variables. Then important things are to understand in this window. What options can we put and what is going to be the use of these options? We can go to descriptives, and here you can take, for example, the KMO and Bartley's test for your further values. So continue, and then you can go to the extraction. Now in the extraction, this is very important to understand. For example, this there are 2 options. Based on eigenvalues, which is equal to 1, by default it is given as 1. Or you can go with number of fixed factors that you want SPSS to extract. So let's suppose if we'll only be using this eigenvalue, we are giving software this option to calculate as many factors as possible. But once we fix it to some number, for example, if I have three variables and I want it to be fixing it to three variables maximum or the three factors, so I have just given it three and I'll continue. But you can always use the other option to know how many factors your data can give. Then we go to the rotation, and these things are also important for different methods. For example, if you don't want to use any of the rotation, then you will by default keep it to none. But you can also use the varimax, direct obligation, and other methods. So let's for now we can use this varimax. It doesn't make much difference, but you need to be very careful for what kind of study or what kind of analysis you're using, what kind of extraction. So continue, and then we can go to the score. We don't have to do anything from here, and the options. Now, in the options, another important thing needs to be calculated. For example, here it says suppress small coefficients. Yes, we want to suppress small coefficients. And let's suppose if we want to take all the values above 0.50, what we can do is we can just give it zero point 0.5. So any values which are less than zero point 0.5 will be suppressed by the software. We'll talk about that when we'll go to our result sheet. So you can continue and just click OK. Now here we have our results, and you can just scroll down. If you want to see the KMO and Bartlett's test, this is 0.812, which is fine. Your chi-square value is inflated, but also fine, and it is significant. These values are fine, and if you want to use them, you can use them in your data interpretation. This is another important table which is showing us this initial eigenvalues. Now, according to the software, any factor that has the eigenvalue greater than 1 can be considered as a separate factor. So, according to the software, six of our factors or six of our variables are shown according to our initial eigenvalues. And here is the variance that is being explained by all of these factors. So let's say 38% of the variance is shown by first, 12% by second, and 7% by the third one. Now, another important thing and the most important thing that we need to look at is this rotated component matrix. Now, here we can clearly see that in the F1, all of its items are loading at one place except F1. So this is required, but we can calculate a few things from here. For example, item 1 is not loading on its factor or loading less than zero point 0.5 because we asked the software to suppress the values which are less than zero point 0.5. So this is one thing. Secondly, if you look at this EC employee creativity, now from EC1 to EC4, the values are fine. But what about EC5 and 6? They are loading at a different factor. They are not loading at their own factor. So this is a problem. This is giving us a little problem that it is not showing that it is measuring employee creativity. Then, if you look at this third variable innovation, some of its values are loading on the employee creativity, and some of the values are loading on the third column. So, there is a problem in this, you can say, data or in this factor loading. Now, here we can see a few problems. For example, for F1, which is the formalization variable, you can see that F1 is not loading on its respective factor. At the same time, if we look at this employee creativity, for example, EC5 and EC6 are not loading on its corresponding factor, but they are loading elsewhere. And in the innovation, or in variable, which is of 9 items, you can see that some of the uh, items are loading somewhere else and some of the items are loading on the creativity scale. The problem here is that if you have to look for the convergent and discriminant validity, the convergent validity says that all of your items of one variable should load on one factor and they all should be above zero point 0.5 or ideally above zero point 0.7. Now, we might have to remove this item because this is giving us problem as one item. But when we talk about the discriminant validity, that means that when they are converging at one point, they should not be loading on any other variable. For formalization or for our first variable, except F1, all of the items are loading on the same factor and at the same time they are not loading on any other factor. So this is fine, but we just need to remove this F1. But the employee creativity scale is giving us a lot of problem, and at the same time, innovation scale is also giving us a lot of problems. So there are different things that we can use. If you want to remove some items, you can do it, but otherwise, this is a problematic data. So we have another sheet in which there are four variables now. So learning organization or LO is a variable of 21 items. Then we have the KC knowledge creation, and that is of 12 items. And then we have the innovation that is consist of 12 items, and then firm performance that is consist of these 10 items. So let's just look at this data, that how this is going to give us results. So analyze, dimension reduction, factor, and we have to put all the items except the, if we have some computer variables. Descriptives, we can take this KMO and Barclays. In the extraction, we can go with fixed number, for example, and we can say we want 4. And then we can go to this rotation, we can use the varimax, and then we can go to this option and we can suppress the values which are less than zero point 0.5. We are going to click OK, and now we're going to look at these results. So if you look at this matrix, it is telling us that LO, all of LO's variables are loading on the same factor and no other factor is being loaded on this. So this is a sign of good loading. First of all of them are above zero point 0.5. Second, all of them are loading at their own factor. And third, no item is loading on any other factor. Now let's proceed further and see that KC1 to KC12, all of the factors are loading on its own KC factor and they are not loading anywhere else. Here, for innovation, all of them are loading to their respective factor and not anywhere else, and the same goes for firm performance. So from here, we can say that this sheet is showing that we have the convergent validity of all the variables. Why? Because all of them are loading on their own factor. And at the same time, we can say that we have the discriminant validity, which means that they are not loading on any other factor. None of them is loading on any other factor. But this is just the indication. The further things that we need to calculate in order to make sure that we have the right values is that we talked about in the CR and AVE values. So how can we calculate the AVE and CR values? So first of all, AVE. So AVE is actually calculated by taking the average of squares of the loadings that we've just seen. For this, we can use Excel. So let's suppose if this is the value of our loadings, we can just put the is equal to sign and then put a bracket and then use this raised to power for Excel. If you're using a calculator, then you can do this. You can give the raised to power. But if you're using the Excel, then you need to give these raised to power signs, and then Excel is going to understand that it is taking the squares. So let's just take these values to Excel, copy, and put them in Excel with is equal to sign, and by clicking this, you will be getting this value, which is 0.62, for example. This value should be above zero point 0.5, and it is way above 5. So we can say that we have the AVE value, which are fine. For the calculation of the CR values, I suggest you that you can go to this website, the statisticalmind.com, and it is going to give us a very simple sheet in which we can calculate our CR values. We are on the website, and first, when you're going to look at this website, it is going to give you this explanation, and you can simply go to this calculator. And when you'll move to the calculator, here you have to give your standardized loading values. For example, for your item number one, let's say we have a value of zero point 0.8, and then you can add another item and you can give the value, for example, 0.68, and then another value 0.84, and then for example another value is 0.98, and then another value 0.78, and then another value of point, for example, 58. So here it is going to give you this calculation of 0.914 composite reliability. So this is the value that you can place in your result interpretation sheet. If you want to delete some items, you can always use these buttons to delete it, and it is automatically calculating the values of the given items. As long as the value of composite reliability and AVE is above zero point 0.5, you're fine. So this is all about our factor analysis video. For any questions, you can give your questions in the comment, and I'll be happy to answer them. Thank you very much.